Same thing. The mother is content number is the competency is this. Okay, we just read that earlier, but we need to read the children competency. Applies number concept and principle to justify and prove the number relationship. Applies the number theory. All right. Which is true? That's the question. Which is true? Which is true? About fundamental theorem of arithmetic. Okay. Fundamental theory of arithmetic. A. Every integer greater than 1 can be uniquely factored into primes. Yes, I think yes. Yes, okay. They're saying this in simple word that any number which they use the word integer because the word integer can be positive or negative. No, we talked about it earlier. Any integer greater than 1, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, can be uniquely factored into primes. True or false? I think that is true. Okay, that is true. Why? 1 times 1 is 1, 1 times 2 is 2, and then 2 times something, any number you multiply can be factored, okay? Or the factor of 1 is 1 times 1, which is 1. The factor of 2 is 1 times 2, okay? The factor of 3 is 1 times 3. The factor of 4 is either 1 times 4 or 2 times 2. You know what I'm saying? That's what they're telling us here, letter A, okay? Now, the next one is every integer. So this looks like true. That's true, no? Every integer is a prime number. We talked about this in the previous problem, no? 1 is a prime number. 2, 1 and 2 are prime number. 1, this is 1, 2 prime number. 3 is a prime number. 4 is sitting as a prime number because they can be 2 and 2 and 1 and 4, right? 5 is a prime number, 1 and 5, no? 6 is a prime number, 1 and 6 or 2 and 3. But this has, so they're telling us every integer, the word every integer is a prime number. True or false? What do you think?
False.
False. It's false because like 6 and 4, there's more than 2 ways to do it, okay? So that's false. Prime factor, oh yeah, we call what we're doing right now is this. Prime factorization is not unique. That's what because that word. True, that word not unique tells us not the answer. Okay, but what I'm doing right now, this is prime factorization. Okay, this is prime factorization. That's what I'm doing right now, prime factorization. But that word not unique, it's false. I'm not gonna choose that answer. Letter D. Can you read the letter D for me, please?
Only even numbers have prime factors.
Okay, what's the negative word there on letter D?
Only.
Only. So on the test, that is a sign. Do not choose me. I use the word only. There's no only in mathematics. Okay, so this is false. So what do you think is the answer?
A.
A is the answer. But is it difficult?
No.
This is just application of the theory. Okay, fundamental theorem of arithmetic. Let's review the child, I guess, competency. Same thing, the same competency, but we need to review. Compare and contrast the vectors, matrices property of number system, okay? Which property is true, okay? Have you noticed I highlight what the conceptual understanding, the true, the correct, okay? Matrix multiplication, but not real real number multiplication. Huh. Can you read that for me again, please? Number 6. Can you read that for me?
Which property is true for matrix multiplication, but not for real number multiplication?
Okay, I highlighted 2 phrases there. What are those phrases that I highlighted?
True and not.
True and not. What are we looking for?
True for matrix and not
Not.
for
Okay.
real multiplication.
Let's focus on the word not, or none. Look at the choices. Before I discuss it, look at the choices, because on the test, you will analyze the problem. Look at the choices. Which do you think is the answer? But by just those 2 highlighted words. Focus on the last word.
Non-commutative?
Not commutative. You see the test. Sometimes that's the answer. By the way, I'm going to discuss it anyway. It's just I want you to analyze it, because on the test I won't be there for you. You'll be the one to read it, analyze the problem. I don't know. You said you took the test several times, right?
2 times.
2 times or 2 times. So these are the things that sometimes confusing part, but just focusing on what is the negative words, it tells you that negative is not the answer, and we're looking for the not the answer. Okay?
Right.
And your choice is what?
Non-commutative?
God, that's the right answer, letter D. But I will tell you, I will teach you how to do this, okay? What's this? Numbers, okay. So that's the answer. A commutative is this. Let's start with A, okay? Although we already got the answer, that not, that's the answer. Let's talk about this. Commutative property. I need to take this off. Commutative property. All right. Can you give me 2 numbers, ma'am?
3 and 7?
Again, 8 and 7?
3 and 7.
Oh, 3 and 7. My bad. I didn't hear. Sorry. So, help me. Okay, commutative property. 3 plus 7. Tell me. What's 3 plus 7?
10.
10.
10.
Good. Let's put it backwards. 7 plus 3.
10.
10. This is commutative property. You switch the orientation or the position of the number, but the answer is the same. Cool?
Yes.
All right, let's do another one. Next is associative property. Association. Okay, let's put, can you give me another number, please?
5 and 9.
Okay. Oh, no, just one number, We'll
5.
use the same. Okay, 5. 3 plus 7 plus 5. Okay, I will put them associative, okay? I will put them in brackets, okay? Okay, here we go. Help me out. Earlier, you said 3 plus 7 is, what's the answer? 10? Okay, 10 plus 5 is still 15, no? Now, in associative property, it's just you're changing the groupings or the association. All right. Okay. So PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction. Okay. Now in multiplication, division, start from left to right. In addition, subtraction, left to right as well. No. Now we're on P or parentheses. Help me. 7 plus 5.
12.
12. That's 12. Plus 3.
15.
Same answer. Different association. Are you getting it? So
Yes.
this is the explanation of the theory of, not theory, or content of in algebra. Now let's go on with distributive. Distributive is kind of easy, it's just multiply. Let's use that number there. Your 3 and 7. 3 plus 7, okay, multiplied by 5. And this is easy. So this is distributive property. Okay, distributive property. Okay. In algebra, if I see parenthesis, what does this parenthesis means in algebra? If you remember. Do you remember? What's the parenthesis means in algebra? Let me know. If you
Yeah.
don't remember, that's okay. Just be honest. Just,
Like
do you
what's
remember?
inside the parentheses or
No. What does parenthesis means in algebra? This parenthesis.
I don't know.
You don't remember? Okay, parenthesis means you need to multiply them. No, basically.
Okay.
That's the meaning of parenthesis in algebra. So it means this 5, I need to distribute this to both. That's basically in algebra. So it's like 5 times 3 and then plus 5 times 7. That's basically what's happening. Okay. So here we go. 5 times 3, we got 15 here.
13.
5 times 7, we got 35. Okay. And then we add that is what? 50 or 50. No? So 5 plus 5 is 10, carry 1. That's 1 plus 1 is 2 plus 3 is 5. So that's distributive property. So again, the question here is what is non? It's negative. So the answer is none. Answer is the 50. Cool?
Yes.
All right, good.